All right, good morning, everyone. Good afternoon, whatever this is. When you guys are watching this video, I hope this finds you in good health and good spirits. Today, what I want to do is take a look at solving centroids for complex shapes. Rarely do shapes come in just straight rectangles and straight semicircles, straight circles, or triangles. Oftentimes they come as composite shapes like you see here. We've done the basic shapes to learn how to solve centroids for basic shapes, and then we did an activity that probably didn't make as much sense as to why we were doing it in basic shapes relative to a 0, 0. I hope to bring clarity and bring those two assignments together today with this lesson on how we're going to solve for basic or complex shape centroids. And step one for solving for complex shapes is to break the complex shape into simple shapes. So if we look at this shape, we can see there are two rectangles here. And if we draw a dotted line across right here, you will have shape 1 and shape 2. And yes, I know you're all loving my ruler shirt tails that I'm rocking here. Don't be jealous, you know you want one. So shape 1 is a large rectangle, and shape 2 is a smaller rectangle, but it's offset. The other thing that we need to do is we need to add a reference 0, 0 to our object. So we're going to add a 0, 0, and this will be what we're going to reference as 0, 0 through all of these shapes. Okay. Now we've broken this object into two very simple shapes, two rectangles, very easy to calculate the centroid for two rectangles. Now, if we take a look, what I do then is I redraw my centroid of my two objects relative to that 0, 0 that I set as a reference. So here's my reference. You can see now that I have two rectangles at 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, which matches what this rectangle up here is 1, 2, 3, 4, 5, 6, 7 blocks by 1, 2, 3, 4, 5, 6 blocks. Okay, and we're going to use a scale of 1 square equals 1 inch, just to make life easy here. Okay, so you can see I have a rectangle here and a rectangle here. Step 3, after we've drawn the shapes relative to their 0, 0, is to calculate the x and y bar, just as we did in our last assignment. Okay, so with a rectangle, we need to get to any corner of the rectangle, doesn't matter which corner. All right, so let's go to this corner on this particular rectangle, right? The x and y coordinates of that location are 0, 0. So we don't have to do any additional adding of distances. We can just straight use the formulas for rectangle on this. So x bar, we know, equals base divided by 2, capital B, because I know my B's look like 6's. Okay. And so the base is 1, 2, 3, 4, 5, 6 blocks wide. So x bar equals 6 divided by 2. So x bar equals 3. Okay. Now we do the same thing with y bar here. And so we'll calculate y bar. Y bar equals height divided by 2, which the height of this object is 7. So 7 divided by 2. Y bar equals 3.5. I'm running out of room, so I'll raise my dot cam up just a little bit more here so I can fit the whole thing in. Okay, now we've calculated the x and y bar. The other thing that we must calculate of each shape is the area. So we have x bar, we have y bar. Now we must calculate the area of shape 1, which the area of a rectangle is base times height, or this case, it is 6 times 7. So the area of shape 1, so I like the subscript, area of shape 1 equals 42 inches squared. Okay. We have to do the same thing to shape 2. Calculate the x and y bar relative to the 0, 0 and the area. So in this case, we need to get to a right angle, or a right corner, one of the corners of the rectangle. So let's go to this corner. This corner's x and y location is over 2 blocks in the x location. So it is 2, comma, it is up 1, 2, 3, 4, 5, 6, 7. So it's 2, comma, 7. So then when I calculate the x bar, I immediately go x bar equals 2. I take my x coordinate and I plug it directly in here. Then I ask myself a question. Is my formula going to take me in a positive direction for the centroid, or am I going to move from the point I'm at in a negative direction to get to the centroid of the object? In this case, I'm obviously going to move in a positive direction, so it becomes plus base divided by 2. This is 2 plus 1, 2, 3, 4. 4 divided by 2. So x bar of this object equals 4. Same thing with y bar. I go y bar. The first thing I do is pull this coordinate from my ordered pair, which got me to the corner, which is 7. And am I going to move, in this case, am I going to move in a positive direction upward, or am I going to move in a negative direction downward? The answer is I'm going to move in a positive direction, so I add height divided by 2. My height is 2, so 7 plus 2 over 2. Y bar equals 8. So I have my y bar and my x bar of shape 2. Add a little subscripts here to these will make your life easier to keep track of everything. Now I also need to calculate my area. So my area of shape 2 equals base times height, which in this case is 2 times 4, 4 times 2. So my area of shape 2 equals 8 inches squared. Hopefully that all makes sense. That right there is everything that we've done so far. And we've added up to and tried to get to this point. Now, what we have to do from this point forward is we need to calculate the centroid of the complex shape. So we need to calculate the centroid of the complex shape. And that is done with a formula that is found on your formula sheet. It looks super complicated. The formula for x bar is the sum of x bar I times area I divided by the sum of area I. All right. Now understand x bar I, area I, all that means is x bar shape 1, area shape 1, x bar shape 2, area shape 2. And it's just however many shapes. You may have to break an object into 5 shapes in order to find its centroid. Okay, so don't let this formula confuse you too much. Okay, it is not over the top confusing. It's just the way it's written. So basically, the sum of xi times ai means for each shape, we're going to take x bar and we're going to multiply it times the area. for each shape. And then we're going to add the areas of each shape up. Okay, so we have two shapes here, so we're going to do this 2 times. Okay, so we're going to say x bar equals the x bar of shape 1, which is 3, times the area, which is 42. So we're going to say 3 times 42. I like to put parentheses around it. It helps me separate it, but it's not necessary. And then we're going to add, because we're adding material to shape 1, shape 2 is adding material to shape 1, we're going to add shape 2 to our system here. Then we take the x bar of shape 2, which is 4, times the area of shape 2, which is 8. And then all we do is put that over top of, that's all of our shapes, the area of shape 1, 42, plus the sum of AI, so 42, plus the area of shape 2, which is 8, and we add them again because that is adding material to shape 1. So if it's plus here, it's plus here. So it's 43 times 42 plus 4 times 8 over 42 plus 8. Okay. Now that simplifies to 126 plus 32 over 50. You should get an X bar for the shape of 3.16. Hopefully that makes sense. So your X bar is 3.16 over, which makes sense. Right? It needs to be a little over halfway in order for us to balance this extra weight that's up here. Y bar is done exactly the same way. So Y bar equals the sum of Y bar I times area I divided by the sum of area i's. So Y bar in this case equals our Y bar of shape 1, which is 3.5, times 42. Again, I like to put parentheses. Shape 2 is adding material to shape 1, so we say plus, and it's plus the Y bar of 8 times the area of shape 1, which is 8, divided by the sum of the areas. The area of shape 1 is 42, plus the area of shape 2 is 8. So we end up, this simplifies out on top to 3.5 times 42, 147 plus 64 over 50, which equals Y bar of 4.22. So your centroid of this object reports is 3.16, comma 4.22 is an ordered pair. Circle your answer, and there is your work for solving the centroid of this simple shape.